Welcome to Module HU002 of Oricon's Upskill Modular Training Program devoted to Revit and BIM. This module is titled Pipe Sizing and Verification and is brought to you on behalf of Oricon by A2K Technologies. We will be using the purchased materials supplied by Oricon and A2K Technologies. Classroom notes and handouts are available for note-taking through the Exemplar portal. Throughout the training today, we will be covering the following topics: Introduction, the Pipe Sizing tool, Check Pipe Systems tool, Show Disconnects, and the System Inspector tool. Introduction. The previous module HU001 Pipe Types and Pipe Systems covered the proper setup of Revit projects for the use of embedded hydraulic calculation and dimensioning tools. In this exercise, we are going to take a look at the sizing of pipes along with the verification. This includes using the tools to automatically calculate pressure loss and fixture units across pipe runs. To follow this lecture, open the Master MEP Hydraulic HU002 model from the Open dialog box. At the same time, make sure that the reference file arclinkmodel.rvt is located in the same directory as the main file. Open the View 01 entry-level drainage layout from the project browser. And zoom into the part of the floor plan between grids 5-6 and AC. Notice that there are some simple examples of pipe systems modeled. A cold water system, which is blue, as well as a hot water system, red, feeding the basin and the toilets. On the other hand, we've got a sanitary drainage system for the toilets, which is green. To get a better overview of the model, close all hidden windows, open up the 3D view 3D 129 toilet, and hit WT to tile windows. This is a very useful way of working, as you can actually see what is happening to your pipes while you size them. Pipe Sizing tool. Use the Pipe Sizing dialog to automatically specify the sizing for sections of pipes using friction and/or velocity sizing methods. In a first step, we will be sizing the cold water pipes. Select a segment of the blue cold water pipe and refer to its properties. Notice that currently it seems to be oversized at a diameter of 64 mm. Let's see now how we can use the pipe sizing tool to correct this to a more suitable size. Hit Escape, and hover over a section of the blue cold water pipe and press the Tab key 3 times until the entire run of cold pipes is highlighted. Select the pipes. In the Analysis tab of the contextual ribbon, select the tool Duct/Pipe Sizing. In this dialog, we have the options of sizing the pipes by way of velocity and/or friction. As an example, set the values as following: velocity to 1.5 meter per second and friction to 250 Pascal per meter. Under constraints, set branch sizing to calculated size only. Do not restrict the size and hit OK. If you look closely, you can notice that the pipes will resize in the background, but you will also get an error message that a line is too short. Your only option now is either to delete the elements that are too short or to cancel the sizing process. We hit Cancel, which resets the pipes back to the size they were before we started sizing them. Not so helpful. The reason this is happening is that the connector on the cold water on the basin is 15 mm in size, and when the tool is sizing to something other than 15 mm, Revit can't fit in a matching fitting within the short space available. Let's look at how we can resolve this. Select the cold water run again, hover over one of the pipes, hit tab 3 times, select the pipe run, and open the duct/pipe sizing tool. Leave the maximum velocity and friction values as they were before, but set the branch sizing to match connector size this time. Hit OK. The pipes should resize now according to the calculations without an error message. The reason that this has now worked is because of the match connector size setting. This is generally the best setting to use, as it will ensure that all branch pipes that connect to fittings will match the connector sizes without a problem. Repeat the same process as before for the red hot water pipe run. Hover over the pipe, hit tab until the pipe run is selected. In your Analysis tab, select duct/pipe sizing. Leave the settings as they are, hit OK, and find that the pipe size is changed to a matching diameter. Things to note. The pipe sizing tool does not work on sanitary pipes. When we select the sanitary pipe run, we don't get the sizing tool to select in the ribbon. Flow calculations and therefore sizing of pipes that are not under pressure or not fully filled with a medium, as sanitary pipes usually are much more complex. For sanitary, the usual workflow is to use the model to calculate the fixture unit totals and size them accordingly. Schedules are very powerful to verify this process. Refer to module HU003 Advanced Scheduling Hydraulic. Check Pipe Systems tool. This tool examines whether each system component is assigned to a system and properly connected. To verify the connections for pipe systems in the model, click the Analyze tab, check Systems, and then check Pipe Systems. Switching it on now should produce no errors, as all the networks are currently assigned and connected properly. However, let's see how we could use this tool to find errors. The tool can be turned on or off for each individual view, so turn it off for both of the views. Activate the other view, make sure that it's turned off. As an example, zoom into the portion of the sanitary pipe system up here, select the pipe, and deliberately break the system between the pipe and the fitting. Select the pipe and drag the pipe away from the fitting, just like that. Hit Escape, go back to the Analyze tab and turn on Check Pipe Systems for this view. Zoom out a bit. And notice that this time Revit displays graphical warning markers and web lines for invalid pipe systems in the current view. Click on the warning marker to review the warning description. Those warning messages give us a good idea about what is wrong in our systems. They display when any of the following conditions are found. First of all, if a system is not well connected, like it is in our case, the system is physically not sound. Second, if there's a flow-demand configuration mismatch. And the third reason could be a flow direction mismatch. Show disconnects. This will introduce a tool to graphically display all disconnects, no matter how small, and highlight them with a warning marker, similar to the warning marker from the Check Pipe Systems tool. First of all, disable the Check Pipe Systems tool, and then select the Show Disconnects tool in the same tab. As we are only interested in pipes, tick Pipes Only and select OK. Notice that warning markers will appear at every open end of a pipe, showing that there is some kind of disconnect. Click on some of the warning markers to display the warning message relating to the issue. This tool can be very useful by allowing you to quickly scan through your model and identify the problem areas that need attention. To turn the warning markers back off, click on the Show Disconnects button once more and untick Pipes. Hit OK, and the warning markers will disappear. System Inspector tool. This tool allows you to inspect the relevant hydraulic parameters of connected equipment and at any point of the connected pipe runs. The System Inspector also isolates the selected system for comfortably adjusting the components. Before using the System Inspector, all systems to be inspected need to be connected properly. The System Inspector will only work on systems that are well connected. Use the Check Pipe Systems and Show Disconnects tools to ensure that the systems are properly defined and connected. In the 3D view, select any of the cold water pipes and start the System Inspector tool on the Analysis panel. This will isolate the cold water system and allow the user to only modify system-related elements. Elements not belonging to the selected system are grayed out. Select the Inspect tool again and notice that color-coded arrows appear on the pipe run indicating the flow direction. The red arrows indicate the critical part through the system. Hover over different sections of the pipe run to display a tag showing the relevant flow and fixture unit information. Click a section to retain the flow information in the view and highlight another section to compare the information for both sections. We hit Escape once to exit the inspector, but the selected system is still isolated and we can only modify the selected system. Once modifications are done, for example, the diameter of pipes are changed, we can finish the System Inspector and retain the changes we have made, or cancel the System Inspector to disregard any changes and exit the System Inspector mode. We select Cancel. Please note that the information that is displayed while inspecting depends on the system. A domestic cold water system will show the flow and fixture units, whereas a sanitary system, once this one's fixed again, will only show fixture units. The System Inspector is not available for fire protection systems. And this concludes the exercises for this module. And that concludes module HU002 Pipe Sizing and Verification.